Okay, so a totally new kind of AI has hit the scene. And these aren't your typical chatbots. We're talking about models that can seemingly think out loud, showing you their work step by step before they spit out an answer. I mean, it looks like reasoning, it sounds like reasoning, but is it the real deal? That's what we're going to dig into.
Yeah, that is the big question, isn't it? Are we actually seeing the beginning of real artificial thought, or is this whole thing just a really, really clever illusion?
So, this is what that thinking actually looks like. The AI creates this trace of its thought process. It explores different ideas. It even looks like it's double-checking its own work before it lands on a final answer. The fancy name for these are large reasoning models, or LRMs, and there's supposed to be this huge leap forward, or, well, that's the story anyway.
All right, so to figure out what's really going on in there, we've got to deal with a huge problem first, and that is, how in the world do you test an AI to see if it's genuinely reasoning without it, cheating the test?
Well, here's the core of the issue, and it's something researchers are really concerned about. See, most of the tests we use for AI are just standard math and coding problems. But think about it. What if the AI has already seen the answers to those exact problems, or ones just like them, somewhere in the mountains of data it was trained on?
That right there is called data contamination. And the best way to think about it is like this. Imagine a student gets a copy of the final exam's answer key a whole month before the test. Sure, they might ace it, get a perfect score, but did they actually learn how to solve anything, or did they just memorize the answers? You can't really know for sure.
So to get around this whole cheating problem, researchers came up with a really clever new kind of test, one they designed specifically to be uncheatable. Instead of grabbing math problems off the internet, they turned to a set of classic, pure logic puzzles.
And this is where you can really see the difference. The old way, with the math benchmarks, was just full of potential contamination, and really you could only check if the final answer was right or wrong. But with these new puzzle-based tests, not only do they avoid that contamination issue, but the researchers can crank the difficulty up or down with incredible precision. And most importantly, they can look at every single step of the AI's so-called thinking process.
So what kind of puzzles are we talking about here? Things like the Tower of Hanoi, checkers jumping, these classics. What they all have in common is that they require pure, step-by-step logical planning. You can't just guess your way through. This setup is perfect for seeing exactly where and how an AI's reasoning starts to fall apart.
Okay, so the stage is set. They ran the tests, putting these new thinking models head-to-head with the standard ones. And honestly, the results were, well, they weren't what anyone was expecting. A really surprising, super clear three-stage pattern started to show up. First up, for the really easy puzzles, something weird happened. The standard models, the ones that don't think out loud, were actually more accurate. It seems like the thinking models got bogged down. They'd overthink these simple problems and end up getting tangled in their own logic, which led to more mistakes. Kind of strange, right? But then, as they ramped up the difficulty to a medium level, the tables completely turned. This is where the thinking models really started to shine. That ability to work through a problem step by step gave them a massive advantage, and they just pulled way, way ahead in accuracy. Now this is what everyone was expecting to happen.
But then came the real shocker. Once the puzzles got too hard, past a certain point, both models just collapsed. And I don't mean their accuracy dipped a little. I mean it plummeted straight down to absolute zero. A total, complete failure across the board.
And the way they failed is maybe the weirdest part of all. You'd think they'd run out of juice, right? Like not enough time or computing power. But no, they actually started to think less. The harder the problem got, the shorter their chain of thought became. It's almost like they looked at the problem, knew it was too hard, and just gave up.
I mean, this sudden collapse is just fascinating, right? So to understand why this was happening, the researchers did the only thing they could do. They dove right into those reasoning traces. They wanted to see what an AI's thought process actually looks like, both when it's getting things right and when it's failing spectacularly. So for the simpler problems, they noticed this pattern they started calling overthinking. What would happen is the AI would actually find the correct solution really early on in its thought process, but then it wouldn't stop. It would just keep going, exploring all these other incorrect paths. Sometimes it would even talk itself out of the right answer it had already found. So, if you map out the journey to the solution, it looks something like this.
On those easy puzzles, the right answer pops up super early, but it's followed by all that useless overthinking. For the medium puzzles, the AI actually has to work for it. It explores a lot of dead ends before it finally lands on the correct solution later on. And for the hard puzzles, the correct answer just never shows up. Not once, anywhere.
But believe it or not, the story doesn't end there. As the researchers dug deeper, they found even stranger things. These little puzzles within the puzzles that make you question everything we think we know about how these AIs work.
Okay, get ready for this, because this part is just mind-blowing. The researchers decided to give the AI the ultimate cheat sheet. They literally gave it the perfect step-by-step algorithm to solve one of the puzzles. And the result? Almost zero improvement. Nothing. Even with the instruction manual right in front of it, the AI couldn't follow the steps and failed at the exact same point. Just wow.
And check out this massive inconsistency. The model was nearly perfect on a puzzle that required 31 correct moves in a row, the Tower of Hanoi, but then it would completely bomb a different puzzle, river crossing, that only needed 11 steps. What that tells you is that it's not about how long the logical chain is. It suggests the AI isn't using general logic at all, but is instead relying on patterns it has memorized from its training.
And all of this brings us to the researchers' pretty stunning conclusion. Their findings really challenge everything we assume about these models. They suggest that what we've been calling reasoning might not be real general-purpose reasoning at all. It might just be an incredibly advanced form of pattern matching that runs into a hard, fundamental wall the second it sees a problem that's truly new.
So we're left with this really profound question. If an AI can't even follow a perfect set of instructions, and if its success is more about what kind of problem it is rather than how logically hard it is, then what is actually going on inside its mind? This throws a huge wrench in the whole direction of AI development. It suggests that just building bigger and bigger models might not be the path to true intelligence. The illusion of thinking, it turns out, is more convincing than ever. But the mystery of what real reasoning is, well, that's still the final unsolved puzzle.